What if the moon suddenly disappeared? What if the moon suddenly disappeared? No romantic nights, no tides, and maybe no life on Earth as we know it. What secrets does it hide? Why is it slowly drifting away? And most importantly, could it actually leave us one day? It sounds like the start of a disaster movie, but the answers might surprise you. Let's dive in. How and when did the moon form? About 4.5 billion years ago, when Earth was young, molten, and utterly lifeless, it got sideswiped by Theia, a Mars-sized cosmic body. This wasn't a gentle encounter. It was a full-on collision that blasted billions of tons of debris into space. These fragments eventually gathered to form what we now call the Moon. Back then, Earth spun so fast that a day lasted just 6 hours. The Moon hovered a mere 20,000 kilometers away, looming in the sky like a giant cosmic spotlight. This catastrophic event didn't just give us a moon. It stabilized Earth's axis, paving the way for seasons and the climate we know today. How did the moon change Earth? The moon wasn't just a cosmic souvenir after its dramatic formation. It became Earth's first stabilizer. Before the moon, Earth wobbled like a drunk spinning top, with its axis constantly shifting. But the moon stepped in as a gravitational anchor, calming our planet's wild tilts and giving us consistent seasons. And those massive tides? Early on, the moon was so close that it caused tidal waves hundreds of meters high, reshaping coastlines and stirring up oceans. This constant mixing of water and nutrients may have even played a role in sparking life. The moon didn't just change Earth. It helped build the blueprint for everything we know today. The first billion years, the moon and early Earth. During its first billion years, the moon was a chaotic and influential neighbor. At such a close distance, it exerted enormous tidal forces that gradually slowed Earth's rapid spin. Days that once lasted only 6 hours began to lengthen bit by bit. These powerful tides caused massive coastal erosion, shaping the early shoreline and fostering the creation of the first coastal zones. During this time, the moon acted as a cosmic builder, stabilizing the structure of Earth's oceans and improving the planet's thermal balance. Its gravitational influence became a driving force in Earth's early evolution. The second and third billion years, Earth and the moon in tandem. During the second and third billion years, the moon gradually drifted farther from Earth, loosening its gravitational grip but remaining a crucial partner. Tides became less intense, and Earth's day lengthened to 12 to 16 hours. This slowdown allowed Earth to cool further, forming stable continents and early ocean ecosystems. During this time, the moon continued to stabilize Earth's axis, preventing chaotic climate swings. Its tidal forces drove the circulation of water and nutrients, laying the foundation for the emergence of complex life forms in the oceans. Together, Earth and the moon progressed toward an era of great evolutionary leaps. The fourth billion years, from the past to the present. In the fourth billion years, the Earth-Moon system began to resemble what we know today. The moon continued to drift outward, reaching its current average distance of 384,400 kilometers. Earth's day extended to 24 hours, and the tides became calmer, but still vital for ecosystems. This period saw the rise of multicellular life, the first terrestrial organisms, and eventually humans who looked to the moon for guidance, mythology, and exploration. The moon's gravitational pull maintained the stability of Earth's axis, ensuring consistent seasons and a balanced climate. Today, it influences not only the planet, but human culture, inspiring science, art, and our ongoing fascination with the cosmos. The Moon's journey away from Earth. The Moon is that friend who says, "I'm not going anywhere," but quietly drifts away by 3.8 centimeters per year. Originally, 4.5 billion years ago, it was just 20,000 kilometers from Earth, looming like a massive cosmic spotlight. Today, it's sitting at a comfortable 384,400 kilometers, meaning it has traveled a staggering 345,000 kilometers over the past 4 billion years. Why is it moving away? Earth transfers energy to the Moon through tidal forces, and the Moon uses this boost to edge farther out. But don't worry. At this pace, it'll take billions of years before it gets anywhere serious. For now, the Moon seems to be saying, "Thanks for the energy, Earth, but I've seen enough of you up close. Time for some breathing room." Could the Moon ever leave us? Mathematically, if the Moon keeps drifting away at 3.8 centimeters per year, it would take 29 billion years to cross Earth's gravitational boundary, the Hill sphere, which extends 1.5 million kilometers. Sounds alarming? Don't worry, it's impossible. As the Moon moves farther, tidal forces weaken, slowing its drift. Plus, in 5 billion years, the Sun will expand into a red giant, consuming both Earth and the Moon long before this scenario could play out. No cosmic breakup in sight. Hypothetical scenario. What if the Moon disappeared right now? If the Moon suddenly vanished, chaos would unfold within hours. Tides would become uncontrollable. Some regions would be flooded by tsunamis, while others would dry up completely. With no Moon to stabilize Earth's axis, it would wobble chaotically, causing unpredictable climate shifts and seasons. Ecosystems reliant on tides, like coral reefs, coastal forests, and marine life, would collapse, disrupting food chains. Over time, life on Earth could face serious threats. The Moon isn't just a celestial neighbor. It's the gravitational anchor holding our world in balance. Why we don't need to worry. Relax. The Moon isn't going anywhere. While it's true it drifts 3.8 centimeters farther every year, it's still firmly in Earth's gravitational grip. Even with billions of years of slow retreat, tidal forces will weaken, slowing the process further. And don't forget, in 5 billion years, the Sun will expand into a red giant and end this cosmic drama long before the Moon could ever escape. So, no need to panic. The Moon will stay our loyal companion, lighting up the night sky and keeping Earth's axis steady for as long as we're around. The Moon. The Moon. It doesn't just orbit us, it's our cosmic partner. Without it, Earth would be a chaotic spinning ball where seasons come and go like bad jokes. The Moon keeps us balanced, like a reliable friend who always has your back. Now it's your turn. What do you think about the Moon? Just a rock, or the foundation of our world? Drop your thoughts in the comments, because even the Moon loves a bit of attention.